My name is Russ Roberts. I'm a product engineer on the ArcGIS Online team, and with me is Kristian. He's also he's a product engineer on the JavaScript API team, and we're here to show you how you can build some 3D applications with the JavaScript API. So we're going to just give you a little bit of an introduction into 3D, some key concepts there. Talk about how you can build with web scenes and leverage them within your application, and then we're going to show you actually how we take hosted layers and a web scene from ArcGIS Online and use those portal items to create a custom application with the 4.3 JavaScript API. Cool. So first, let's talk about 3D. Within 3D, we're mainly leveraging these 3D optimized layers called scene layers. They're great for handling large amounts of data, but you can also use feature layers if you wanted to. We do support in scene views WMTS layers, tiled map layers, and feature layers and scene layers. So you have readily access to all those layers, and you can use them with an ArcGIS Online or portal. Oops, just go back, sorry. So yeah, they're powered across services across the platform. You can use your 2D content with features that aren't Z-aware, so they can be just draped over the surface of the globe or the scene. Or you can use 3D layers with Z content, so you could do extruded buildings if you wanted to, multi-patch features, or lines or points that have Z values that you can use within a local or global scene. And it helps create a different context than seeing things in 2D. So you can add this different visual element when you're using these 3D aware layers. So I mentioned this whole global or local scenes in that last slide, and it's a little bit of a key concept when you're thinking about creating a 3D application. What are your goals, and how should you kind of display it? So you can use, if you're using WGES84 data, you're going to be restricted to using a global scene because we support that only on global mode within that sphere. So you can use a mix-up of Web Mercator or WGES and global scenes. You can use global content within a global scene, or you can use, like in our sample today, we're using data that's in WGES84, but it's localized around New York City. But if you have projected data, you could use it at Web Mercator or any other projected coordinate system. You can use that in a local scene. So if I just want to have downtown Manhattan and clip an area or clip an extent, I can use a local scene for that. Local scenes are also great for subsurface data, kind of like at the plenary when I showed those the earthquakes and smart mapping. A local scene is really good for showing that subsurface data, so you get that kind of aquarium view. And you can clip the extent within a local scene to the extent of your data. You can just do that in Pro, or when you're actually authoring the web scene itself in ArcGIS Online, or you can do it in the JavaScript API. And to talk about how you would do this stuff in code, here's Kristian.
All right, so how do you build a 3D app with the JavaScript API? It's really quite simple. Let me move that down a little bit. So we have the concept of a map and then a view. The map is what controls the data that you want to display in your application, and the view determines how you display that data. When we're talking about 3D, we're always going to talk about scene views and scenes. And it's, as you can see here in this code snippet off to the left, creating a basic 3D app is really quite simple. You just create a new map, you add a base map to it. Esri provides several just out of the box for you. You can also use a custom base map in local scenes. I'm not sure about global, but in global you have access to the Esri base maps. And then you just set that map object within your scene view, reference your view container, and then you have a scene. The viewing mode is global by default, so you technically don't need to set that. But if you want to set a local scene, then that's where you're going to set it in that property. So here's a look at a local scene. Notice that the viewing mode now says local. It's just a simple string. And in the example, I've set a clipping area in southern Kansas, and I'm able to render oil and gas wells and earthquake locations. So you can see data underneath the surface of the earth. So you can do some pretty cool things in 3D with just a few lines of code. Something else that's important to understand with 3D is the concept of a camera. In traditional 2D mapping, we talk about extents. If we are talking about the web, 2D for the web, we mention things like zoom level, maybe the center point of the map. But in 3D, some of those concepts don't make a ton of sense. Imagine if you're zoomed out to, say, this extent in the image. How do you define that extent with a rectangle? It's really hard to. If you see the screen of the image, that the screen points of that image don't match up with points on the earth. So defining an extent is very difficult in 3D. We do have an extent property on the view, so you can certainly use that. But I recommend using the camera because you can set things such as the position of the camera, that's the X, Y, and Z value, and then the tilt of the camera, where you're looking on the horizon, and then the heading, are you facing north, south, east, or west? And the tilt, in this image, it's referred to as pitch, but in the API we call it tilt. So there's a code snippet of how you would set a camera in the scene view. All of these, the position property, AutoCast says a point object in the API. So you don't actually need to import the point, Esri geometry point module. You can just set a simple object to X, Y, and Z values, and then set the tilt in the heading. So let's go ahead and look at a live view of how this might work. So let's focus on, let's see. Can you guys see that code okay? Is that, okay. So I've just got a simple HTML file. I'm bringing in the API via CDN, the 4.3 API. And then, as you can see, just a few lines of JavaScript, not a whole lot going on. I'm bringing in my map and my scene view modules, and I'm just setting a simple base map to the Esri Streets base map layer, and then setting the container of the view to this view div, which you can see down here in the HTML. And then I'm setting that map object to the map property. Really quite simple. So if we take a look, this is what you get with that code. Just a basic 3D view of the world. So let's go ahead and change it up a little bit. Let's change it to a local scene. See what that looks like. So that's not going to be in the map. That'll be in the view object. So viewing mode, local. I'll refresh that. And then you see it has the appearance of a 2D view, but in reality it's not 2D because I can tilt this. See that? And if I enable navigation underground, I can actually navigate underneath the surface there as well. So that's pretty cool. But this view isn't necessarily useful on a global scale. It can be useful on a global scale, I should say, but I think it's particularly useful, like Russ said, for projected coordinate systems, you need to use this view. But if you want to look at just a small area, you can create a local scene and clip it to that small area. So let's go ahead and clip to Palm Springs. So you'd set the clipping area. I've already got that here. Let's paste that in. Notice that I'm setting an extent object to the clipping area, and you might be thinking, wait a second, he's contradicting himself. He said to not work with extent objects. It's a little different now since I'm in the local viewing mode. Now that it's flat, it's easier to set those extents. So we can use these XY bounds to set an extent. So I'm gonna go ahead and save that, refresh, and oops, I don't see anything. The reason for that is because this is a small extent, and I didn't set the extent of the view itself. I just set the clipping extent of the view. So those are some things to consider. You might be confused by this at first, but just note that there's an actual data view, but because you set that, it doesn't mean your camera is going to go to that view. So I can set the extent property right here to the exact same extent and get the view I want. But instead of doing that, here's the Palm Springs area. I'm going to just set a camera to show you what that looks like. So let me paste this over. And notice I'm setting just a simple latitude, longitude for Palm Springs. I want it 500 feet above sea level. So this is an absolute position. And then, or actually, sorry, I believe this is 5 above the surface. And then I'm setting the heading to look west. So I want to look at the mountain and setting a tilt there. So I'm going to go ahead and save it, go back over. And now I'm looking west towards the mountain, but then you're thinking, wait a second, where's the mountain? It disappeared. I can't see it. So I'm going to turn it back over to Russ, and he's going to talk about elevation layers.
Thanks, Kristian. So elevation layers, we provide a global one that you can use in global scenes and local scenes. Our world, I should call it a world elevation layer that you can use in the global scene and local scenes. Yeah, they help provide a context to your map, like looking at Palm Springs without any mountains with the heading. Doesn't really give you a good frame of reference in 3D. You can publish them to Portal or to ArcGIS Online or to your server by using either ArcMap. Within Pro, you can actually create a scene within Pro and set your elevation layers, your elevation sources within the scene. And when you share that to your portal to create a web scene, it'll generate the elevation layers for you to use within an application like the scene viewer or a custom one. And so yesterday I actually did a little demo of how you could do this for ArcGIS Online. You would just package up a tile package with your elevation data with a Lurk tiling tile format. And what you get is, I'm just gonna switch over to my screen. Sweet. So here I have Mount St. Helens. I have it clipped down to a little area to show Mount St. Helens after the eruption, which is from the Esri world elevation layer. I just clipped it down to this extent. But then I was able to find some before data with a slight exaggeration that I added from the USGS website. And so I just packaged that up into a tile package, but with Lurk tile format and within Pro 1.4. And then I was able to upload it to ArcGIS Online and create a hosted elevation layer to use within the scene viewer or within a JavaScript application. And just to show you that you can use multiple elevation layers within a scene, so you don't have to just remove them. You can have them together and they can exist together within a common scene. So Kristian's going to show you how to bring an elevation layer into the application that he's building right now.
All right. Elevation is controlled in the map object. So we don't control elevation in the scene view. It is rendered in the scene view, but we handle the data component in the map. So just keep note of that, because the same map object can be used for a 2D map view as well. So when you're using a 2D map view and you set a ground property, it's just going to ignore it, so it doesn't do anything. But when you render this object in a scene view, you're going to get an elevation layer. So the concept of ground, like Russ said, is just showing an elevation surface. And in the future, we may do more than elevation, like show surfaces below the surface of the Earth, bathymetry, maybe geologic type things. But right now, we just support elevation layer. And as Russ said, you can publish your own and reference the URL there from the image service in the layers property. But most of the time, I'm guessing you might just want to take advantage of the default world elevation service, and you set that in the ground. So let's take a look at that. And So I'm going to go up to my map object, and then I'm going to say ground world elevation. And refresh. And now I can see the mountain and the elevation. So really just one line of code and you get some more vertical context to your map. So then some other things to keep in mind with building 3D apps is navigation. You can do manual navigation with the mouse and the keyboard. Obviously, I've been doing that in these demos so far. But you can also control that programmatically using the go-to method. And this is a really slick method that can take any number of objects for navigating. In this particular animation you see, I'm passing in a graphic. So just a single graphic object, and the view will navigate to the extent of that graphic. As you can see in these code snippets, you can also set any number of properties. I can set a center point, like a latitude, longitude point, a zoom level, a tilt, a heading to set when I zoom to that area. You can pass in a whole camera object. You can pass in a geometry. You can pass in graphic, array of graphics, array of geometries. It takes any number of things and will go to the extent of those objects. So like I said, it's a really handy API to work with. And so if I switch back over to this app, let's say I want to navigate to some other place in the world. Let's say Zurich, Switzerland, because I happen to have that latitude longitude point. So we're going to talk about the view.then statement or method a little bit later. Basically, when I call view then, I am waiting for the view to be ready. And then I'm going to call the go-to method on the view and set the latitude longitude to Zurich, and then I'm going to set these other properties to get a view. So I'm going to go ahead and do a set timeout and say to 5 seconds. I'm just going to paste that function in there. So we can give ourselves enough time to let the data load. And since Zurich is outside the extent of my clipping area, I'm going to go ahead and remove that. I'll remove the viewing mode as well. I want it to be global. So I'll go back and refresh. And after 5 seconds, it'll start the navigation. And it goes all the way around the world. And it will go to those exact properties that I set in that object. So again, cool little API there for you. And you know, we work a lot with graphics and features. When you do analysis, maybe you're doing queries. Once you perform the query, you can just call this method, pass those features in there, and it will navigate to those. You can also set these tilt and heading properties with your graphics. Let's say you zoom to the graphics, but you want to have it tilt to it. You can also set those along with them within an object. So you can also do some cool visualizations with the API. I did a 3D visualization session yesterday. If you didn't catch that one, I encourage you to take a look at it. There's a lot of content. I only really give this 1 or 2 slides in this session, but I encourage you to get on to look up the session, the recording later. It's all the sessions this year are free, so you can look that up and learn more about visualization. These are just some tips and tricks to keep in mind. You can set 2D icons on your point data. You can control options such as billboarding them. So when you move the camera around, the face of the icon is always facing you. Or you can drape it on the terrain so it looks like it's draped. And you can set the sizes in screen units because it takes up screen space. Whereas the 3D symbols, those objects and extrusions and those tubes that you might see in some of our samples, those sizes are expressed in meters. So those are some things to keep in mind. Also note that we have environment settings on the view that you can set to set the lighting, and those impact things such as color. So if you're doing thematic visualizations such as those in these images, just keep some of those things in mind because it might mess with traditional cartography that your users might be used to. This is just a quick code snippet showing how you can create a symbol with the API. And symbols in 3D are controlled on the symbol layer level. Again, I'm not going to delve too deeply into that because it's a bigger topic. Just know that that session is available, and I've also written blogs about this. I've written documentation about it, and hopefully all those things make sense. And if they are still confusing, be sure to give us feedback and let us know how we can improve that. But I'll go ahead and just demonstrate adding data, say, into this app. So you can also add things like widgets. So if I can bring in a base map gallery widget. Let me paste this in, and then I'll go over the code to show you what it's like. And I'll bring in all these modules and paste them in here. And there we go. So what's going on here is I'm just going to create a new base map gallery. I'm passing in the scene view. I'm going to create a div element because I'm going to reference that node in the expand widget. The expand widget is new. It allows you to hide these bigger, bulkier widgets so it doesn't take up too much of your view. And you'll see what I'm talking about when I demo it. And then I'm going to place that expand widget within using our UI API. So instead of needing to set a specific position or CSS, I can just drop it into the top left of the view below all the other widgets. I'm going to go ahead and get rid of this. I don't want to animate to Zerk anymore. I just want to display a layer. So I'm also bringing in a feature layer. Believe the layer is zip codes. So here's a feature layer. Russ is going to talk about scene layers a little later. I'm referencing the URL, and then I'm setting a renderer on it. It's just a simple renderer where I set this 3D symbol within the layer. So this is object symbol 3D layer. It's a layer. It's a symbol for, or it's a symbol layer for symbolizing points. But notice that it's also within a polygon symbol because these zip codes are polygon geometries, not point geometries. But I can take the centroid and place a cone on the centroid, and set properties on it to drive my data. So, for example, I'm going to set the width and the depth of that symbol, so basically the diameter, to 500 meters. Remember, these are not screen units, these are real world units. And this visual variable down here indicates that I want to keep that constant for all my features. However, for the height of those cones, I want to drive that based on the data. So I'm going to set it on this field, average household income, and I'm going to say for those houses or those households where they make $40,000 a year on average or less, I'm going to set the height to 250 meters. If it's 100K or more, we'll say 8,000 meters or 8 kilometers. I'm going to also set a color visual variable to make the visualization easier to interpret. Because of the 3D perspective that you see, so if I have a tilted view of the Earth, some cones that are the same height are going to appear smaller in the distance than those that are close to you. That's just kind of natural perception, right? My hand in front of me here is the same size as this hand, but to me it looks a lot bigger. So that's why I'm going to set the color, because of those cones that are further away but maybe taller than ones in front of me. I want to know if they're actually higher. And then I'm just going to add that layer to my map and save it. And let's go ahead and refresh. And data might take a while to come in because it's I believe it's all the zip codes in the US, but that's what you get. Simple visualization like that. You can tweak the values a little bit. It looks like my data's, the values and stops I've set are a little skewed, so I get a lot of tall cones, but you get the idea of what you can do with visualization. So I really encourage you, if you missed that session, go ahead, look it up, watch it, and then you can play around with your own data. I'm going to go ahead and turn the time over to Russ now, who's going to talk about web scenes.
Thanks, Kristian. So yes, we have a concept of web scenes, just like web maps, that you would use in with web maps that you use in the 3x or the 4 within the 3x or 4x API. But within the 4X with the API with webscenes, you can read them in directly from the portal item because in the webscenes we support reading and writing them in the scene API in the 4X API, kind of like what Joe showed at the plenary with him reading in a web scene that I had authored within the scene viewer, and then he was able to update it and update it and push it back to the portal. So yeah, you can use the scene viewer to author these web scenes, and we're going to be showing that a little bit later. Or you could be authoring them in Pro as well if you want to do it through an out-of-the-box application. So you can share that directly to your portal or to ArcGIS Online. And if you were creating an application, you could use the 4X one to read in those web scenes and update it and push it out if you wanted to. So these web scenes, they're a great container for all the layers, elevation, operational, base map layers. We have a spec up on developers for ArcGIS Online, developers at arcgis.com for you to check out. So if you want to understand some of the objects and properties that exist within a web scene and what you should expect when you're reading in these properties, I recommend you to check it out because it goes over the concepts of slides and the ground properties in good detail. So something we've kind of touched over throughout this presentation are the scene layers. And these are the 3D optimized layers that you can use within a web scene or a 3D application. You can bring them into Pro, or you can use them in these online applications. We have an array of different scene layers, like a point scene layers, which can be generated from a scene layer package or from a feature layer. We have the 3D object scene layer, which is good for extruded buildings or multi-patch features. That can be also generated now in 1.4 in a scene layer package, or you can publish it actually from a feature layer in ArcGIS Online today. So I'm going to be showing that workflow in a minute. And then we also have an integrated mesh scene layer, which is more of a photorealistic that was captured either through drone to map or if you use the i3s spec that we've released, you can generate your own integrated mesh scene layers like Vricon does with the Yosemite sample that Adrian showed at the plenary. We also actually have one that we recently released that we also showed. It's the point cloud scene layer, and that's generated from like a LiDAR last data set, and you package it up in Pro 1.4. You can create that scene layer package, and then you can actually upload it to ArcGIS Online, and that'll create that point cloud data set that you can use in the scene viewer to visualize the configuration, the default configuration that you set when you create that scene layer package. But the API itself actually has the ability to leverage all the attributes like RGB values for you to do some further customization. And that's planned to come to the scene viewer, but you can further customize it in the API now. And those point cloud scene layers are going to be coming to Portal 10.5.1. So in the next updated portal, you'll be able to create scene layers and use them within the scene viewer within the API. So I'm going to show you how you can actually create these scene layers. Within ArcGIS Online, you can either publish it directly from the feature layer if it's a supported geometry, so either point or multi-patch to create your point scene layer or your 3D object scene layer. Or you can also upload those scene layer packages depending on how you're delivering your data. And then after I show you how I actually create the scene layer, I'm going to bring it into a web scene. And then once I finish creating this web scene, I'm going to hand it over to Kristian to further customize it and leverage all that 2D and 3D content within a custom application. So it should be on my screen now. And so here we have, like in Pro, I just wanted to show you what the content looks like. This is just some multi-patch data coming from a file geo database. And it's just some building floors in New York City with a couple of attributes. So you can see as I click on it, it's highlighting the different floors because I divided them up and extruded from the polygons and then created a multi-patch from it. But what I'm going to show you, so you could either share this up as a feature layer from ArcGIS Pro. If you're using ArcMap, you can take that multi-patch and share it from ArcMap to ArcGIS Online, and it'll still be a multi-patch feature layer that you could publish from ArcGIS Online. Or if you, let's say, downloaded this from an open data site and it came in a zipped file geodatabase, you can go ahead and just take that zipped file geodatabase. And first, what this is doing here, it's going to publish that a feature layer. So this is just going to be generating that feature layer of those exact same buildings. I'm just going to jump over to a feature layer I actually just published while Kristian was talking and show you that from the item detail page. So at the plenary, I showed how you could do this with a point feature layer to publish a point scene layer. And well, this is a 3D object. This is a multi-patch data set. But if you look at it, when it comes into 2D, it just looks like flat polygons. And we want to use this in those like 3D optimized scene layers. So I just go to the publish option on the item detail page, and I'm just going to select the scene layer option. It's in beta right now. It's something we recently released, and we plan to be in final at the time of UC. And if your multi-patches had actual textures when you packaged it up, those textures come across as well. So you don't lose them and just get gray buildings, like in the simple example that we have here. So if you're using textures, those actually come across as well. One thing I want to point out, towards the bottom, we have this display in global scene or local scene. Because the scene layer is a cached layer, and these are all light applications, we can't reproject them on the fly. So you need to kind of think about it when you're publishing these layers. Am I going to be using this in New York State plane projected coordinate system? Or am I going to be using this in a global scene because, let's say, I'm taking advantage of other scene layers that might be in a global, like I'm using some scene layers published by another Esri employee that they're all in WGIS 84 or Web Mercator, and I want to use them in a global scene together. So I need to have all my data sets that are cached in that same coordinate system. So my tile layers are in Web Mercator, and they can be used in a global scene. But this data set, I'm going to be using it in a global one as well. So you want to remember that when you're about to publish this, because you won't be able, you'd have to delete the layer and then go back and republish it as a local scene if you wanted to. So you can't reproject or alter it like you would be able to with a feature layer. So I'm just going to go ahead and publish this as a 3D object scene layer to be used in a global scene. And this begins the publishing process. It'll start building that scene layer cache, and then once it's completed, I can actually bring it into the scene viewer or into a custom application. And one thing I also want to talk about, when you publish through this kind of workflow, something that we've recently added to ArcGIS Online when you publish scene layers from feature layers. Let's say in the case of like the tree data set with all those New York City points, if I had a collector team out there that was using the feature layer to collect more trees and they've made changes to that data set, I can actually rebuild this scene layer cache when those changes have been synced up to that feature layer. So I don't have to delete this scene layer and break, let's say, applications that are associated to the portal item ID. So I can update this scene layer cache whenever there's changes coming from that feature layer. And we're working on seeing how we can pick up any of the changes automatically so you don't have to manually do it. So I'm just going to go into a new scene. And I already have a cache already built. So I'm just going to open up a new scene, and search for the layers that I want to add into this web scene. So I'm just going to use like a simple study area. This one's just a polygon just to kind of show the area of focus that we were using. Like I mentioned before, you could be using ones with textures. So here's a some textured buildings that I published in this case, I published it from a scene layer package, but I could also do it if I published it from a feature layer. Here's that data set of the surrounding buildings that I wanted to use. And I can actually add in the untextured buildings as well. So these are the 4 layers I'm going to be using. The other thing, because we have a shared spec, any of these edits that I'm making, when I save this scene and give the item ID to Kristian, he can pick up and read those, everything that's being authored within this web scene. So like base maps that are being used, or the slides, so I can highlight focal points of a scene. It can actually read in all the, there we go. It can read in all the layers that are on and off at a given time. And I can update them whenever I want, and they pick up the changes. So it's really handy if you have kind of bookmarks and you want to save the layer states. Slides are actually a really helpful thing that you can use, and you don't have to do anything special to get them to work in the applications because it supports reading the slides, and Kristian's going to show you how to do that. The other thing that we have within the 4.x API, it's a concept of grouping layers. So I can create a group layer. I'm just going to drag it up to the top. We have different types of groups. We have like a checkbox, which means you can have it's like the standard layer list where you can check all your layers on or some of them on and off. Radio, which means only one can be on it at a time. So if I do the 3D objects, the 2 different types of building layers, if I go over to my layer list, I can only have one of these layers on at a time. So it's a really handy thing as well, depending on the application that you're kind of building. If you don't want the mashup of having the 2 3D objects layers on top of one another where you get the conflicting between the textures, this is a handy way to kind of prevent your users getting into that kind of workflow. We also have the merge, which can actually make all these layers look like one layer within the layer list itself. So if you don't want to give them the option to switch off any of the sublayers at all, you just want to show one layer completely in the layer list, you would use the merge. Or you can actually hide it completely from the layer list. And the layers will still be present within your scene, but for the layers will not show up in the layer list or the legend at all. They'll just be pretty much operational layers that your users won't be able to turn on and off at all. They're just kind of locked in there into the scene. And if we were having an application that was going to be using the environmental, because these are 3D environmental features, because these are 3D features, we could be able to take advantage of the environment widget. And once I pause it, because I changed the time of day, I can go back to one of my slides, and I can capture another slide, and this will also capture that environment setting. So that time of day also gets locked into that slide and would show up in the application that Kristian used, will be building. And then I can just save these changes. And once it saves, I now have the item ID. And I just wanted to show you guys what I talked about before. Now that I have that completed web scene, but I want to go back and actually show you that now that this cache has been built, if any changes happen to that data, that feature layer, I would just go into Manage Cache. I'd pick the layers that had been altered within this cache, select them, and then I can start the rebuild process. So that's what I was talking about with the rebuilding of these scene layer caches, so you don't have to delete it and do it, and refine the item ID and update any scenes, web scenes that might be leveraging this actual scene layer. This is how you would actually update them and keep everything up to date. So to show a completed web scene. Kristian's going to use that and build an application around it and show you some cool stuff that you can do in the API. Thanks.
All right, thanks, Russ. That's pretty cool how you can rebuild that cache instead of having to republish your layer over and over again. So I'm going to go ahead and talk about what you can do with that scene to build a custom JavaScript application. We have a portal API in both 3x and 4x, but in 4x it's a lot nicer to work with. You can load your scene using the portal API, and then you can work with the properties of the web scene that Russ customized, like the slides, and then you can alter those using custom visualizations and pop-ups. Because Russ had those non-textured buildings, and they have different floors, and if you wanted to thematically visualize what's going on, maybe by usage type or how many days the floor has been on the market, you can't really do that in the scene viewer right now. It's limited in its ability to do data-driven visualization. You can do data-driven visualization with point data in the scene viewer, but not with these objects with the buildings. So I'll go through and talk about how you can customize that. So here's the scene that Russ built. What you're going to do is grab the item ID and then use that within the web scene class. So instead of using a map object, you're going to bring in the web scene. The web scene is a class that extends map, and I'll show you how you can use that within your scene view. And so then notice that that scene object is placed in the map property of the scene view. So like I said, it just replaces the map. So it's kind of hard to talk about portal without talking about the loadable pattern. So a lot of times in our documentation, you'll notice that we talk about resources that are loaded versus not loaded. And this just simply demonstrates what loaded means. So when we have a resource such as a web scene, we call the load method to load the data. But when that promise resolves, it returns a promise. When it resolves and returns the loaded state, it doesn't mean that all the buildings have finished drawing in the view. That's a common question we have. What it does mean is that the data is, or the resources are immediately accessible to you in your application. It doesn't really have much to do with what's going on in the view, and I'll demonstrate what that means. The way that you can know that you have access to your resources is by calling the then method on the view. And you saw that when I did that animation to Zurich, I called then and waited for the view to be ready before I did that. So let's go ahead and take a look. So I'm going to grab this ID and then go into my application, and let's go back to this one, and I'll take out all of this code because now that Russ configured a web scene for me, I no longer need all of this. I don't need to set my own layers because he created his own layers there. And let's keep world elevation. We don't need the layer. Let's see here, view. So we have the view div, camera, that's already set, that's configured in this web scene. So we're reducing the code a lot. So let's go back down to this. And like I said, when we're talking about web scenes, we no longer need map. We're going to bring in the web scene class. And then instead of setting a base map, because that's configured, we're going to set a portal item. And that is the ID that he gave me. Oops. Let's go back and grab that. And then we're going to set that to the view. I'm going to be consistent here and name this the web scene object and set it to the map property. Okay? So you can see how bulky your code can get if you have more than one layer and you set renderers on it. It can get pretty bulky really fast, and then but by configuring a web scene, you reduce it back down to this size of an application. So I go back to this app, I'll refresh it, and then I have the initial state of that web scene that he created. So pretty cool that you can in just like 10 lines of code get all of that data in 3D and bring it into your app. But if you want to work with the scene properties, you need to call view.then. and then you have access to the web scene when that promise resolves. Oops. Let's go back here. And then, so I'm gonna call, so let's just log the web scene. So you can take a look at those properties. And then I'm going to refresh. And here's my web scene. So notice that that object was available to me in the console before the data drew. So I had access to the layers within my scene, so those buildings layers, the base map object, and then even this portal item object, which gives me things such as the ID, when it was created, who created it. If it's a public item, you could see what rating it got, like 5 stars or 1 star. In this case, no one's rated it. So then there's like a title, the New York study area. So I'm going to show you what you can do with those in a custom app. So I added onto that simple application and did some things to it. So I created a couple of UI elements. They're not super pretty, they're just basic elements like divs, where I can go through my slides and put them in there. And so I can allow the user to toggle layers on and off. And you'll notice that these buildings look a lot different than the buildings that Russ created, and that's because I'm adding a renderer to it custom within the application. I'll show you how I did that. I like these Lego colors. I have small kids, and so we play with Legos, and I wanted to be a little playful and use these colors. But I'm rendering each floor of the building based on its usage type, whether it's a commercial use or residential or mixed. Again, these aren't traditional colors for those use cases, but you can do what you want with the API. And notice that when I click on the slide, I get all of those properties of the slide. I get the base map, I get the viewpoint. You can use the slides for navigation, so you don't have to call the go-to method. You can just call the apply to method on the slide. I'll show that in code as well. So you can provide regional context to your project. You can get some other overview, or maybe mimic a 2D overview with the satellite imagery. You can do a lot of cool things with just the slides. So if we go back here, I also provided drop-downs. What's new in the 4.3 API is that you can filter your data in a scene layer. You couldn't do that before. So if I just want to show my residential floors, I can filter those out and just display those. Or commercial. And then there's the mixed use. And then you can, I'm going to go back to this thematic view. I like the lighter base map when I'm dealing with these colors. Then I added a checkbox to show the days on the market. So I'm adding a visual variable on top of it of color. So I'm rendering, I guess if I go back to this view, you could see these gray floors indicate that that floor is not on the market. It's already being used. But these darker floors indicate that they've been on the market for quite some time. And I do that for each of these. So it maintains the filter and it changes the visualization. And then I also added a pop-up that I customized that just puts in a simple table that shows how many days it's been on the market, maybe the height of the floor, and then building type. Or I think there's building name as well. So we got the building name and then a website property even. So it's really, in concept, it's quite a simple app because Russ configured all of those properties in the web scene. I can then play with those and do different things to them. So what does that look like in the code? So again, I called the view.then property, and now I can gain access to the properties of my item. So I have that title on the top of my UI, so I want to display the title of the web scene there, so I can just pull that from the portal item and display it there. Then I have access to the slides using the presentation property. And again, let's go back to this application. Can you guys see the console okay, or do I need to blow this up a little bit? You can see it? Okay, good. So just making sure. Sometimes, yeah. So if I want to look at the web scene slides, I go to the, this is portal item. So let's go back to layers, presentation. So it's in the presentation property here. I can drill into it, and these are my slides. It's a collection, so I can drill into those. I have the title of my slide right there, the ID, the environment settings that Russ was talking about that you can configure, the base map. You can even add a description. We have a sample in the API that shows that you can work with that. You can't really configure that in the scene viewer, but if you want to create a custom map to allow users to do that, you can. There's the viewpoint, the visible layers that you can toggle on and off, and even the thumbnail. That's how I'm able to display that image in the UI. So I encourage you to just build simple apps like this, play around with the data, see what you can do with it, and you can build some pretty amazing apps. And so I want to set the render on that thematic layer. So I'm just going to use the find method on the collection and return the thematic buildings layer and set a renderer. And that's after I create this slides UI. So here's the slides property. Let's see here. I guess I'm not showing that yet. I can show the code and how that works. But so these are the properties of the slides on the view. We already went over this. And here's the function I'm using to create the slide elements, those thumbnails, add them to the UI. I'm just basically iterating through each slide and then saying, I want to add a new div element with the thumbnail. I want to put the title of that slide above it. And then I want to set up a click handler. So when the user clicks it, I want to apply those properties of the slide to my view. And that's simply with the apply to method. You can see how simple that is. Like, instead of configuring all of that with go to and toggling layers and then setting your environment settings on each click, you just have to call that simple method and then pass in your view, and all those properties are applied to it. So then you can obviously create the custom visualizations. In this case, I'm using unique values, and then I'm also applying a visual variable on top of it. You can also do things with extrusions like you see in that other image to the left. That one has nothing to do with this app, but just letting you know you can do stuff like that. And so this is what the renderer looks like. I'm creating I wrote a function called create symbol. It just returns a mesh symbol 3D, and it returns it with the color that I pass in and to the parameter. And I set it into a unique value renderer based on the usage report field, which is indicating the usage type of the floor. And if it's commercial, I'm going to give it that blue color, and residential yellow mixed pink. And as you can tell, like, these values are numeric, so those aren't very helpful to the user, so you're able to set the label on those in the legend to make it more readable. And then the visual variables, again, quite simple. You just pass in an object to the array. So in this case, I'm only using color, and I'm going to drive it based on how many days it's been on the market. So you can set up stops and map values to specific colors. And that's really all there is to it. You can configure how they interact when the user clicks them, and then you can also add a pop-up. So I'm adding this pop-up template to format a pop-up programmatically, and again, pretty basic stuff, but using the webscene API and the portal API really simplifies the code for you. And so that's basically all there is to it when it comes to creating 3D apps using the webscenes. So I'm just going to show you really quick in the documentation. Go ahead and look in the documentation. We have an API reference for the webscene property or object, and then it describes these workflows and how you can work with them. I'm also posting all of this code on GitHub. It's actually already available. So here's my GitHub page. If you go to conferences, Dev Summit 2017, and then these are all my sessions I'm presenting, but this is the 3D apps guide, and I have these demos here along with the slides. And we encourage you to use the app, rate us, tell us how we did, was the content relevant, and That's all we have. So do you guys have any questions before we head out? Yes.
Do you create scene layers or web scenes on the fly, or do you have to author those in Portal or Pro?
I'll have Russ take that question.
Sorry, can you just repeat it one more time? Sorry. Cool. Yes.
Can you create a scene layer or web scene on the fly, or do you have to author that in advance with Pro and Portal?
So the question was about authoring like web scenes or scene layers like on the fly, and are they required in Portal or Pro or online? So you can't. So in online, you'll have to publish the layer like for the scene layers. You'll have to publish them from either a feature layer or from the scene layer package. And the scene layer package is going to require you to build that cache beforehand within Pro to create that using the create scene layer package tool, and then you'd upload that to ArcGIS Online, and then you would have to publish, and then that would publish it on the fly, or we'll publish that for you, but it won't be like a dynamic generated thing. And then with online, you have to author it all through the scene viewer, not on the fly kind of thing. You'd have to author it there, or you'd have to author it through Pro. Or you could use Kristian could have built his application to any of those changes that he was doing with like renders and stuff. He could push that back to the web scene itself, and then the scene viewer, because they all share that common spec, could read it elsewhere.
Yeah, that was that was something I forgot to mention. You can, when you make changes to your scene layer or your web scene, we actually have a save method where you can save the stuff that you can create an app to configure and then push it back to your scene. So that's also pretty cool. That's new to the web scene API. Not available in web maps yet, just in 3D right now. Did you catch that?
So the question was asking like if you could do any analysis with the lighting that I showed briefly in the scene viewer. You can't grab any attributes from that right now. Today it's just a purely like a visual like inspection. So if you had something for your constituents and you were putting in a new building, and let's say you could toggle with the before and after with that like radio, and the environment which it would still be running around showing the continual day, or you could switch it for a specific day with every month of the year, kind of see how the position changes throughout the year. But there's no like attributes kind of being pulled from that. So it's more of a visual analysis that you'd be getting out of it than being able to like apply let's say attributes from the feature and seeing its impact on the environment lighting. So it just takes whatever's present within that 3D object or the 3D features and kind of casting its shadow throughout the time of day. And so like if you did it January versus June, you would see a different extent of your shadow. No, yeah, you can't do that today. It was a question. Yeah, sorry about that. Cool. Any more questions? Do you want to show your GitHub page again? And can you update your photo to a bearded version? So.
I think I look handsome in that photo, so I'm not going to change it.
Cool. Thank you.
There it is. Yes, question.
Yes, yep. You could add additional layers in there. So like in the plenary demo that Joe did with the garbage bins, so he took my original web scene and then he added in the bins and applied that styling and everything. So yeah, you can add and remove layers and you just push the updates when you write out a new web scene to like override it. So yeah, you can add new layers in and then update that scene.
Yes, yeah, absolutely. You can add the layers. Yep. You can add layers and you can save it back to the scene if you want. Yep.
Yep.
Yes?
Your data, did you guys just make that up? Or did you just have some source data in the elevation?
So I created like a little rule, and so I had like the building footprints, and I knew the number of floors, and then I guesstimated the height of each of the floors, so I was able to kind of stack that up and then apply some attributes to it. So yeah, that was data that I made
So it's
up.
not real.
Yeah.
You made it up.
But it looked really good. But yeah, I just created a rule to do that, and so you could do that. You could divide. I used in that case to make the data. I created a CJ. I created a rule within City Engine to kind of do that because City Engine has a great new tool within 2016. I think we're at 2016.1 or 2, and 2017 is coming out later this year. That's how they number their updates, but it allows you to actually grab data from OpenStreetMap. So like for those buildings, I was able to, I grabbed the buildings and it had the number of floors in that data set, and then I was able to create a rule to divide it up. And then you can export out as a multi-patch, or you can export it out as a scene layer package. And so in this case, I exported it out as a multi-patch because I wanted to bring it into Pro to do some more stuff with it, to do more easier editing of attributes, adding fields and that kind of stuff to it. Or if I wanted to, I could just take the exported file database if I was happy with it from the City Engine, upload it to online just like I did in this demo and create the 3D object scene layer from it. Or just use the scene layer package. And so there's a whole lot of workflows that you can to kind of create those 3D content. So if you are a City Engine user, you can do a bunch of these workflows that I showed today too. Cool.
Can you control the speed of the go-to function? Like if you have a linear feature, you have a focal point.
Yes, you can control the duration. So yeah, you can make it go faster. You can actually pass in a custom function to show like different animation options. And we have, let me pull up a sample of that right now. We've added several new scene view samples in this latest release. Actually, let's just right here. And let's do go-to. So using go-to in scene view. Really encourage you to check this out. So it shows kind of the default animation. It shows a slower one. And then like linear. You can do an exponential increasing speed flight. And you could set the time there, so you can check out the sample to show all those options that are being configured. So this is the custom. You can set custom easing, or call other methods. So yes, that's possible.
Thank you, everyone. Thanks for coming.
Yeah, thanks for coming. Come by the island if you have questions.